Right now, as we record this, two NASA astronauts are floating outside the International Space Station 250 miles above your head, rewiring the station's power grid in the vacuum of space. We've got the full story. Plus, asteroid DNA, a solar storm heading our way tomorrow night, a moon rocket on the move, and Blue Origin's plan to defend Earth from killer space rocks. It's Wednesday, the 18th of March, 2026. This is Astronomy Daily.
Hello and welcome to Astronomy Daily, your daily briefing on everything happening in the cosmos and closer to home. I'm Avery.
And I'm Anna. We are deep into a week that feels like the universe is trying to grab our attention all at once. And honestly, we're here for it.
Genuinely, every story today has something remarkable about it, so let's get straight into it. Story number 1, and it is happening right now.
At around 8 o'clock this morning Eastern Time, NASA astronauts Jessica Meir and Chris Williams stepped out of the International Space Station's Quest airlock and into open space, beginning ISS Spacewalk number 94.
This one was a long time coming, Anna. It was originally scheduled for January the 8th, back when a different crew was meant to suit up. But then something extraordinary happened. The first ever medical evacuation from the International Space Station forced the early departure of the Crew 11 mission, and everything was reshuffled.
Right, and this is why the EVA you're hearing about today, right now as you listen to this episode, is the very first spacewalk of 2026. The 278th spacewalk in support of space station assembly, maintenance, and upgrades since construction began.
Meir and Williams are out there preparing the station's 2A power channel for future installation of another Rollout solar array, the 7th of its kind. These IROSA arrays, as they're called, are like accordion-style solar panels that unfurl once installed, and they've been systematically boosting the station's power generation capacity.
For Jessica Meir, this is her 4th spacewalk. For Chris Williams, it is his first, and what a debut. 6.5 hours in vacuum installing a modification kit and routing cables on the port side of the station.
A second spacewalk, EVA 95, is already planned to prep a different power channel, the 3B, for yet another future solar array installation. That one is tentatively set for April 1st, which, yes, is also the day Artemis II is scheduled to launch. April Fool's Day is going to be a very busy day in space.
If you want to watch the spacewalk or watch the replay, depending on when you're listening, NASA covered it live on NASA Plus, Amazon Prime, and YouTube starting at 6:30 a.m. Eastern. Worth a look.
Story 2 is a genuine jaw-dropper, and I want to give it the space it deserves.
So, scientists have now confirmed that samples collected from the asteroid Ryugu contain all 5 canonical nucleobases, the molecular building blocks of DNA and RNA, all 5: adenine, guanine, cytosine, thymine, and uracil.
For listeners who want the slightly deeper version, nucleobases are the chemical letters that encode genetic information. DNA uses 4 of them: adenine, guanine, cytosine, and thymine. RNA swaps in uracil for thymine. Every living thing on Earth, every bacterium, every plant, every animal, every human being uses these 5 molecules as the foundation of their genetic code.
And we just found all of them on a rock that has been hurtling through space since before the Earth existed.
The samples were brought back to Earth in 2020 by Japan's Hayabusa 2 mission, a spacecraft that flew 300 million kilometers to asteroid Ryugu, landed on it, fired a small projectile to kick up material, collected the debris, and flew home. The total haul was about 5.4 grams of pristine asteroid material. That's barely more than a teaspoon.
And from that tiny sample, just about 20 milligrams for this study, researchers at Japan's JAMSTAC agency, led by biochemist Toshiki Koga, extracted and identified all 5 nucleobases, published this week in the journal Nature Astronomy.
Now, the researchers are careful to say, and this is important, the presence of these molecules does not mean life existed on Ryugu. What it does mean is that the rock chemical ingredients for life can form in space without any biology involved at all, and can be preserved inside asteroids for billions of years.
And here's where it gets really interesting for the big picture. Ryugu is a carbon-rich asteroid, a C-type, and they found all 5 nucleobases in roughly equal amounts. That's a different ratio to what's been found in the Murchison meteorite, which fell in Australia in 1969, and different again from the asteroid Bennu, samples of which were returned by NASA's OSIRIS-REx mission.
Those differences actually reflect the different chemical histories of each space rock, different environments, different temperatures, different amounts of water and ammonia they were exposed to billions of years ago.
But here's the headline. We now have pristine samples from 2 different asteroids, Ryugu and Bennu, both showing the presence of life's key molecular ingredients. That strongly suggests these molecules are widespread across the solar system. And that raises a profound question. Did these molecules rain down on early Earth via asteroid impacts and help kickstart life here?
The panspermia hypothesis, the idea that the building blocks of life, or even life itself, can travel between worlds, gets a little more evidence every time we go looking. And stories like this one remind me why sample return missions are so extraordinarily valuable.
Story 3. If you're anywhere in the northern hemisphere, and quite a few in the south, listen up, because you might want to set an alarm for tomorrow night.
On March 16th, active region AR4392 on the Sun erupted with an M2.7 class solar flare. That's a moderately strong flare, and it hurled a coronal mass ejection, or CME, directly towards Earth. NOAA's Space Weather Prediction Center has issued a G2 moderate geomagnetic storm watch for March 19th, with a chance the conditions could ramp up to G3, which is classified as strong.
G2 conditions can push aurora displays to latitudes as far south as New York, the upper Midwest, and similar latitudes in Europe and Asia. G3, if it materializes, could extend those sightings even further south, possibly as far as Illinois.
And the timing here is really interesting from a science perspective. The CME is expected to arrive on March 19th, which is essentially the vernal equinox, and that matters because of something called the Russell-McPherson effect.
Named after geophysicists Christopher Russell and Robert McPherson, who first described it in 1973. Around the equinoxes, Earth's orientation in space puts its magnetic field at a right angle to the incoming solar wind. That geometry makes it much easier for charged particles from a CME to punch through our magnetosphere. So even a relatively modest storm can produce far more spectacular auroras than you might expect.
Basically, March and September are statistically the best months of the year to see the northern lights. And we have a CME arriving right at the equinox. Aurora chasers call it Aurora season, and this year it's living up to the name.
The peak activity is expected overnight on the 19th, so the evening of Thursday the 19th into the early hours of Friday the 20th. Get yourself somewhere dark, away from city lights. Check the Aurora forecast apps, Space Weather Live, My Aurora Forecast, and keep an eye on the KP index. If it's climbing toward 5 or above, go outside and look north.
And remember, aurora displays depend on the orientation of the CME's magnetic field when it actually arrives, which is notoriously hard to predict until it's almost at Earth. The forecast could change, but right now, the signs look promising.
Story 4, and this one is another one that's genuinely unfolding as we speak. The Artemis II moon rocket. The massive space launch system carrying the Orion spacecraft and its 4-person crew is about to roll back out to Launch Pad 39B at Kennedy Space Center in Florida.
And I say about to because the exact timing is being decided today. As of the latest update from NASA, engineers finished their closeout work faster than expected. And as of this recording, they're deciding whether the rollout happens as early as tomorrow, Thursday the 19th, or Friday the 20th. Either way, it's happening this week.
Here's the backstory. The rocket first rolled out to the pad back in January, but 2 wet dress rehearsals, those are full fueling simulations, uncovered issues including a liquid hydrogen leak and then a helium flow problem. The rocket rolled back into the vehicle assembly building in late February for repairs.
Engineers replaced a dislodged seal in the helium system, fitted new flight termination batteries, replaced a seal on the core stage liquid oxygen feed line, and just recently replaced an electrical harness in the flight termination system. No further wet dress rehearsals are planned. The next time the rocket is fueled, it'll be for the real thing.
NASA is targeting April 1st for launch. They have windows running from April 1st through to the 6th, with additional dates later in the month if needed. The crew is Commander Reed Wiseman, pilot Victor Glover, and mission specialists Christina Koch and Jeremy Hansen of the Canadian Space Agency.
If this launch goes ahead as planned, Glover becomes the first person of color to reach deep space. Koch becomes the first woman, and Hansen becomes the first non-American citizen. It will be the first human mission to the vicinity of the moon since Apollo 17 in December of 1972, over 50 years ago.
The mission itself is a 10-day free return trajectory around the moon and back. No lunar orbit, no landing. But they will travel farther from Earth than any human being has ever, passing roughly 5,000 miles beyond the moon. And it sets the stage for everything that comes after.
This is the moment the whole Artemis program has been building toward. The rollout, whenever it happens in the next day or two, will be live-streamed by NASA and takes about 12 hours, with the rocket traveling 4 miles to the pad at about 1 mile per hour, slow and steady.
And Story 5, a look at what Blue Origin has been quietly working on in the asteroid defense space.
Jeff Bezos' space company has partnered with NASA's Jet Propulsion Laboratory and the California Institute of Technology to develop a mission concept called NEO Hunter, Near Earth Object Hunter. The goal, build a spacecraft capable of detecting, characterizing, and deflecting potentially dangerous asteroids before they become a problem.
The platform they're proposing to use is Blue Ring, Blue Origin's modular spacecraft bus that can carry up to 4,000 kilograms of payload across as many as 13 connection ports. It's designed to operate anywhere from low Earth orbit all the way out to deep space destinations, including Mars.
NEO Hunter works in 2 phases. Phase 1, the spacecraft deploys a swarm of CubeSats to rendezvous with a potentially hazardous asteroid and characterize it, measuring its mass, density, composition, and precise trajectory. That information is critical because the right deflection technique depends entirely on what the asteroid is made of and how fast it's moving.
If the asteroid is manageable, Phase 1 also deploys an ion beam emitter. This is fascinating. The spacecraft fires a concentrated stream of charged particles directly onto the asteroid's surface. The force of those particles over time is enough to nudge the asteroid onto a slightly different path. It's extraordinarily precise, it's non-destructive, and if you have enough warning time, it works.
But if the asteroid is too large or moving too fast for the ion beam to be effective, NEO Hunter switches to Phase 2, what Blue Origin calls robust kinetic disruption. The spacecraft simply crashes into the asteroid at up to 22,600 miles per hour. Before doing so, it releases a smaller dedicated camera satellite, which they've brilliantly named the SlamCam, to document the impact and confirm mission success.
The SlamCam, I love that name.
It's very honest marketing. This is, of course, the same basic approach NASA's DART mission demonstrated in September 2022, when it successfully changed the orbit of the asteroid moonlet Dimorphos. DART proved the concept works. NEO Hunter would be a more sophisticated, multi-tool version of that.
And it's worth noting, planetary defense is getting increasing attention right now. The asteroid 2024 YR4 grabbed headlines earlier this year when it briefly appeared on NASA's impact risk list before being ruled out. Asteroids fly past Earth uncomfortably close more often than most people realize. Having a commercial platform capable of rapid response is genuinely valuable and smart.
Blue Origin described it as another example of how commercial platforms like Blue Ring can conduct a low-cost, high-priority science exploration and planetary defense missions. No launch date has been announced yet, but the concept has been developed with JPL, which gives it serious scientific credibility.
And that is a wrap on today's Astronomy Daily. What a lineup! A live spacewalk, the molecular ingredients of life found on an asteroid, a solar storm en route, a moon rocket preparing to roll, and a spacecraft that may one day save the world.
Just the normal Wednesday, really. If you're heading outside tomorrow night to look for the Aurora, we want to hear about it. Find us on socials everywhere as Astro Daily Pod, and share your photos. We'd love to see them.
And if you've enjoyed today's episode, please subscribe wherever you get your podcasts, leave us a review, and share us with a friend who thinks space is cool, which, let's be honest, should be everyone.
Astronomy Daily is part of the Bytes.com podcast network. Find full show notes, transcripts, and links at astronomydaily.io.
From Anna
and Avery, clear skies, and we'll see you tomorrow.